This is lesson 5.4, equations of linear relations. This is the last lesson of chapter 5. So to recap, we know that the equation of a line is represented by y equals ax plus b, where a is the rate of change and b is the fixed term or the starting value. So if we're given a graph, first we want to find out how can we create a table of values from this graph, and then we can figure out how to create an equation from it. So to make a table of values, it's pretty straightforward. You're just going to pick any point on the graph and figure out what those x and y coordinates are. You're going to write the coordinates in the table and then repeat until you have, I don't know, about 3 to 5 points, enough to know what the pattern is. So in this example, we have our linear relation and we have 3 distinct points there. So I just figured out the x and y values for each. So the first one is x has 2 and y has 1. So I put that in the table and I repeat for the other 2 points. This one is over 3 up 3. This one's over 4 up 5. And then I just put that into the table. And then you can recognize the pattern. The y's are going up by 2. The x's are going up by 1. A little trickier is to write an equation when you're given a graph. So we know that our equation looks like this, y equals ax plus b. So it makes sense that we need to find our a and we need to find our b so that we can sub them into the equation. So given the graph, first we want to find the fixed term. This is pretty easy to identify because the fixed term is the y-intercept on the graph. So the y-intercept is where the graph crosses the y-axis. So remember, the y-axis is the vertical one, the x-axis is the horizontal one. So wherever our linear relation crosses the vertical axis, that is the fixed term. And the reason this is true is because the y-axis is at the point x equals 0. And remember, our starting value is when x equals 0. Once we find the fixed term, we need to find the rate of change to get our a value. The rate of change can be found by comparing the distance between any 2 points on the graph. So it's going to be the distance traveled up or down between these 2 points divided by the distance traveled right or left between these 2 points. So if you're traveling between 2 points and you're going up, then that is a positive value. If you're traveling between 2 points and you're going down, then it is a negative value. If going between 2 points you are going right, then it's positive. And if between 2 points you're going left, then it's negative. So up and right is positive, down or left is negative. And then we just sub it into our rate of change. And we just put it into our equation. So what does this look like with an example? We're given this green equation or this green graph here. We want to write an equation for it. So the first step is to find our fixed term or our starting value, which is equal to our y-intercept. So that's what I've identified right here. Where does our linear relation cross the y-axis? So that is at point 1 right here. It crosses the y-axis at 1. So that is going to be our b value. And again, this makes sense because this point here is the coordinate over 0 up 1. Our x value is 0 and our y value is 1. So that's our starting value because it's when x is equal to 0. Next, we have to find the rate of change. You can pick any 2 points and compare the distance between them. So I just picked these 2, but it doesn't matter which ones you pick. So going from the bottom point to the higher up point, we traveled up 3. So the up point is going to go on top, whether you're going up or down. And then we traveled to the right 2. So we went to the right 2. And this translates to positive 3 over positive 2, because remember, going up and going right is positive, going down or going left is negative. And this is a fully reduced fraction, 3 over 2, so that's our rate of change. Finally, we just put it into the equation here. We replace a and b with the values we just found, so y equals 3 over 2x plus 1. So you might be wondering, what if you had compared 2 other points on the graph? Because I did say that you can pick any 2. Would the rate of change be the same? Yes, it would, because all linear relations have a consistent rate of change. So it doesn't matter which 2 points you pick, it's always going to be the same rate of change. The thing to remember, though, is you have to always reduce your fractions. Because if you don't reduce your fractions, it might look like they're different rates of changes, but once you reduce it, it should be the same. So for example here, in gray, we have our linear relation. So in green, I picked this point here and this point here to compare. So I just picked any 2 points. Traveling between them, we went up 3 squares and to the right 3 squares. So that would give us a rate of change of 3/3, which is 1, because we reduced that fraction. Let's test to see if we had picked another 2 points, would we get the same rate of change? So that's what I did in blue here. Going from this point to this point, I went up 2 and I went over 2. Up and right, those are both positive. So the rate of change would be 2/2, which also reduces to 1. So you see that it is the same value when you fully reduce. It doesn't matter which 2 you pick. Another example, write the equation of this graph. So the first step is to find the y-intercept because that is our b value. Y-intercept is easy here. It goes right through the middle. That's at the point 0, 0. So when x is 0, y is 0. So our b value is 0. Next, we find the rate of change. We pick any 2 points to compare. So I picked those 2 points. Doesn't matter which ones. Going from this point down to the other point, I traveled down 2 squares. I went down 2, and then I went to the right 4 squares. So that is going to translate to a rate of change of -2/4. The reasons it's -2 is because anytime you're traveling down, that's negative. If you're going to the right, it's positive. But remember, you have to always reduce your fraction. -2/4, it reduces to -1/2. So make sure you reduce it. And then we just put it into our equation. Replace the a and b with what we just found. And then you'll notice, since our b is 0, we don't even have to write it. There's no point in writing +0. So you just take it out of the equation. It's just y equals -1/2 x. So if you ever see an equation, like maybe you had y equals 5x, and there's no b part to it, that's because b is just 0. The y-intercept or the fixed term is 0. There's no point in writing it. And that is it for how to write linear equations when you're given a graph. This is the homework from the workbook for this section.